The Kepler mission, hunting for Earth-like planets. The Kepler mission, hunting for Earth-like planets. In the vast expanse of the universe, the ultimate question that has intrigued humanity for centuries is, are we alone? Are there any other Earth-like planets out there, capable of supporting life as we know it? The search for extraterrestrial life has captivated the imaginations of scientists and space enthusiasts alike. And in this quest, one mission stands out: the Kepler mission. The Kepler mission, named after the famous German astronomer Johannes Kepler, was launched on March 7, 2009 by NASA. Its primary objective is to discover Earth-like planets orbiting other stars in our galaxy, the Milky Way. This remarkable mission sought to answer one of the most profound questions of our time: is Earth a rare gem in the cosmos, or are there other habitable worlds out there? By continuously monitoring the brightness of a vast number of stars, Kepler can identify the telltale signs of a planet crossing the face of its host star. The heart of the Kepler spacecraft is its photometer, a highly sensitive light-detecting instrument capable of measuring the brightness of stars with extraordinary precision. This precision is crucial for detecting the tiny changes in brightness caused by a planet passing in front of its host star. By constantly observing thousands of stars simultaneously, Kepler increases the chances of detecting these transit events. Kepler's field of view is strategically chosen to maximize the potential for discovering Earth-like planets. It observes a patch of the night sky in the constellation Cygnus, known as the Kepler field. The choice of this specific region was not coincidental, as it contains a rich population of stars similar to our own Sun. By focusing on these Sun-like stars, Kepler increases the likelihood of finding Earth-sized planets within the habitable zones of their parent stars. The habitable zone, sometimes referred to as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. Water is a crucial ingredient for life as we know it, making the search for planets within habitable zones a top priority for the Kepler mission. Kepler's initial mission was planned for 3.5 years, but due to its remarkable success, its mission was extended multiple times. Over the course of its active mission, Kepler has made significant contributions to exoplanet science, revolutionizing our understanding of planetary systems and their prevalence in the cosmos. One of the most astonishing discoveries made by Kepler is the sheer abundance of planets in our galaxy. Before Kepler, we knew of only a handful of exoplanets. But with the data collected from this mission, we have now confirmed the existence of thousands of exoplanets, with thousands more awaiting confirmation. Kepler has shown us that planets are not just a rarity but rather a common occurrence in our Milky Way. Among these exoplanets, the Kepler mission has identified numerous rocky, Earth-sized planets within the habitable zones of their star systems. These findings are of immense significance, as they suggest the possibility of habitable environments beyond Earth. While these planets may not necessarily harbor life, they represent the best candidates for potential exploration and further investigation. One notable exoplanet discovered by the Kepler mission is Kepler 452b. Dubbed Earth's cousin, this planet orbits a star similar to our Sun and resides within its star's habitable zone. Kepler 452b is just over 1.5 times the size of Earth and has a year that is only 20 days longer than ours. This discovery not only fuels our curiosity but also highlights the potential for finding planets that closely resemble our own. But the Kepler mission's capacity to discover Earth-like planets doesn't end with its initial data collection. Scientists are continually analyzing and interpreting the vast amount of information gathered by Kepler, uncovering more secrets hidden within the data. To aid in this analysis, The Kepler team employs innovative data processing techniques and collaborations with astronomers and scientists from around the world. By pooling their expertise and resources, they can refine the methods used to identify potential exoplanet candidates and verify their existence. Unfortunately, every mission has its limitations, and the Kepler mission is no exception. In 2013, one of the reaction wheels, vital for keeping the spacecraft precisely pointed, failed, rendering the original mission plan unachievable. However, NASA engineers ingeniously devised a way to utilize the pressure of sunlight to assist in stabilizing the spacecraft's pointing, giving rise to the innovative K2 mission. The K2 mission is an extension of the original Kepler mission, enabling the spacecraft to continue its search for exoplanets despite the loss of a reaction wheel. Although the data collected during K2 is not as precise as the original mission, it has allowed for the discovery of additional exoplanets and has expanded the mission's scientific reach. The legacy of the Kepler mission is profound. Its discoveries have transformed our understanding of the universe and have provided tantalizing hints that Earth-like planets may be commonplace throughout the Milky Way. While the Kepler mission has come to an end, its impact and significance will be felt for generations to come. It has not only expanded our knowledge of the cosmos but has sparked our imagination and instilled a sense of wonder about our place in the universe. As we continue to explore and study the stars, the Kepler mission will stand as a shining example of humanity's relentless pursuit of knowledge. Kepler's ability to detect the subtle changes in a star's brightness as a planet passes in front of it has revolutionized the field of exoplanet science. One of the remarkable aspects of the Kepler mission is its focus on finding Earth-like planets within the habitable zones of their parent star systems. By targeting Sun-like stars in the Kepler field, the mission increases the chances of finding Earth-sized planets with the potential for habitability. Kepler has made significant discoveries of rocky, Earth-sized planets within habitable zones, tantalizing us with the prospects of finding environments that could potentially support life. While the presence of these planets does not guarantee the existence of life, they represent promising candidates for further exploration and investigation. One such notable discovery is Kepler 452b, often referred to as Earth's cousin. This planet's similarities to our own Earth, such as orbiting a star similar to our Sun and residing in the habitable zone, underscore the possibility of finding planets that resemble our home. The sheer abundance of exoplanets discovered by the Kepler mission has shattered previous notions of their rarity. Before Kepler, only a few exoplanets were known, but with the data collected from this mission, thousands have been confirmed, and countless more await verification. This wealth of knowledge has demonstrated that planets are not an anomaly but rather a common occurrence in the Milky Way galaxy. The Kepler mission's impact extends beyond the initial data collection. Scientists and researchers continue to analyze the information gathered by Kepler, pushing the boundaries of exoplanet science even further. Collaboration with experts from around the world and innovative data processing techniques enhance the methods used to identify and verify potential exoplanet candidates. Although the Kepler mission encountered challenges, such as the failure of a reaction wheel, NASA engineers devised a creative solution that allowed the mission to continue.